So I think all are here now, right?
No, Binay has not joined it.
So are we waiting for Vinay?
You can give me one more a minute to Vinay. If he doesn't join, you can probably start.
He's joining in 2 minutes. Just I got a message.
Okay.
Okay, fine.
Sure, Kaka, timing. What are we going to cover today?
Yeah, sure. I mean, yesterday, Sunil demonstrated you about, I mean, he mostly, I mean, uh, introduced you to the multi-chain theoretically. I mean, all the background behind multi-chain, what is multi-chain, and how actually multi-chain works, and it solves your problems, your custom problems, and how is it possible to use multi-chain as a private blockchain. I mean, he just introduced to all of you guys about these concepts, but today we are actually going to see how we can use multi-chain in a private way, so that we can use it for our own use cases and I mean, to develop our own private applications based on that. So
Oh, that's
today's
good.
session will be completely practical. I'll be showing you guys how to set up the multi-chain, how to configure it, how to play with the commands, and how to browse the multi-chain and all.
Very good. Sure, Kaka. As Sunil was saying yesterday, that we can have some time on coming weekend. So can we go for a, any use case and after that designing blockchain application and setting up all together in this private blockchain? So okay, before going that, so today it means we will set up our private blockchain, then another blockchain, and then we will communicate between those.
Yeah, I mean, today we'll be using multi-chain. Okay, so in multi-chain, you can create your own assets. I mean, asset can be anything like, uh, I mean, your regular example of, Karnataka government's land record on a multi-chain. So, how to implement that kind of use case, we'll be looking at that today. I mean,
Uh,
it will be giving you a complete picture today, how basically blockchain can be used, for your custom use cases to solve your private, use cases and problems, which will be on the multi-chain platform.
okay.
Yeah. So the application
So
that I'll be demonstrating today is enough for to term it as a application on a blockchain, because that is again built up on top of the APIs and all. So we can modify that same application as well, or we can build another one if we want, or it will be like on your choice. If you have some completely different use case, then you can design on top of it. But it's like a vanilla application built on top of multi-chain, which will show you how to create your own asset and or transfer that asset over the blockchain.
Okay. So also, time being, one more thing on testnet. On that day, means after that I followed. I created my account, and
Mm-hmm.
in fact, 10 accounts I created. I was able to transfer money from one to another account. In the same way, suppose that some other person is also creating some account on testnet, then
Okay.
I think so I should be able to send money to him too.
Yeah, sure. I mean, any address on the testnet you'll be able to send him.
Okay.
Yeah, these are like tokens. I mean, last time what we actually saw, these are tokens on top of Ethereum. So, if your token is, published on the testnet, and you know the address of the recipient to whom you want to send some tokens, in a similar way that we saw last time, you can enter his address and send some amount to him.
Okay. I was thinking that all the accounts are only on my computer, but
No, no,
that is
no.
not the case.
These are on the test net. I mean, you can see it on the Robstein network, right? So Robstein.etherscan.io shows you that address live on the test net. So that's a live address on the test network.
Okay. And Kaka, one more thing related to that on smart contracts we created. So,
Okay.
what is the actual use case of Swarm?
Use case of.
Swarm, SWARM, which is used for storage in Ethereum.
Okay. So I mean, the one use case is a currency. Okay. Storage is, I mean, something that you can uh, if you know the key value storage, okay, and basically record management, in that case you can use it as, it's a kind of, I mean, the similar concept is there in today's session as well. It is called streams on multi-chain. So I'll be showing how exactly streams are useful for as a database, I would like to say, simple time series database on top of blockchain. I mean, we will be coming to those examples specifically in today's session, so it will be much
Okay.
clearer to you guys.
Okay, you mean the storage will not be the part of blockchain itself, but it will be saved somewhere else.
Storage, I would say, see, your contract has some storage associated with it. Okay, so when your
Okay.
contract is published, I mean, you have your uh, state variables in it, and these state variables can be like of any size. I mean, it depends on you how long the string you define in a state variable, and how big you can fit a string in a contract. So all these values, I mean, when you're transferring something, or whenever you're executing some transaction over the network, so it requires some storage for that. I mean, to store those values, and while it is getting mined, so that kind of storage is required. So I think
Okay.
Vinay has joined.
Okay. Yeah.
Hey Kaka, good morning. Sorry, I'm late.
Hey, no issues. So I think we are good to go now.
Yeah, we can go. Sorry about that. Yeah.
No issues, no issues. Okay, guys. So in today's session, we'll be seeing like how to deploy private blockchain using multi-chain. So basically, the first step would be like setting the private blockchain. That means we have a multi-chain project already, which is open source by the community, and we'll be setting up that project on our machines, and post that we'll be plugging our custom use case on top of that. So then creating a blockchain means, so when a multi-chain is installed, multi-chain is basically a platform, I would say, and on top of that, I mean, in that multi-chain, you have to create a chain to start with. So if you remember, I had talked to you about the Genesis block on a chain. So chain only starts when there is at least one block in that chain. So then only you can call it as a chain. So creating that genesis block will say that your chain is ready, and that can be now extended to unlimited. So after that, once you create your chain or your blockchain on in the multi-chain, then you should be able to connect your chain and see how many blocks are there, uh, like what is the current state, how many users are associated with that, how many nodes are connected to your blockchain, what is the permission given to each and every node, and how everyone is connected to your uh, chain. Because blockchain is a peer-to-peer network. You don't have a single server where you can say that, hey, I have this server and all are connecting to this server, and this is my network. In peer-to-peer, it is not the case. I mean, everyone can connect to you. There is no server dependency. There is just a network node required. So suppose I'm creating a chain and I am adding Sridhar on the network. So what's either, I mean, if you have followed yesterday's session from Sunil, so in multi-chain, the only difference is that, I mean, here you can control the permissions uh, on the network. I mean, the public blockchains such as uh, Bitcoin and Ethereum, you don't have any control over who can join it. I mean, anyone who downloads the blockchain can simply become a node on the network. But in the multi-chain, you get a control, a dashboard basically to give the rights to each and every node specifically about the exact actions that that node can do. So we'll be seeing that again. Then we'll be running some commands to get you all familiar with the different, the CLI commands offered by the multi-chain. Vinay, can you mute your mic? There is some noise coming. Yeah, that's fine. Then we'll be seeing like how to create our own custom asset on the chain that we'll be creating. Okay, it can be anything. For example, we can create a coin, we can create a land record, we can create anything that is there in the real world. Like we can create say a diamond. For is a good example, which in the diamond industry what happens is that every stone is valuable, even if it's a very small entity. It is valuable, and the history of that stone or the diamond needs to be very carefully stored or managed, because anytime when a diamond comes for a sale, it has to be traced right from its birth, like how much work has been done on it, how much, what was the previous rate it was sold on, its carat value, and the other color value, shape value, everything. So that is one of the example. Like we can push a diamond industry on the blockchain. We can create coins. We can pull. I mean, we can push land records on it, like that. I mean, any custom asset we can create and manage on the multi-chain. Then we'll be seeing like transaction metadata. So whenever you push any transaction, any transfer of the asset or anything which is associated with the network. So on the multi-chain network, so any change or any modification, for example, suppose I want to assign some permission to node 2 from node 1. So suppose I'm the owner of the private blockchain and I want to associate or disassociate some access rights from the node 2, then I have to push that as a transaction on the network. So these are like type of transactions that flow on the network. So we'll be seeing those. Then we'll be seeing streams. So streams, if I don't know if Sunil has covered it yesterday, but streams are like, I mean, it is kind of a database you can say, which is there on the blockchain, and it helps you to just store key value storage. If you know about the NoSQL databases like MongoDB. So all these are like key value storage databases. So even blockchain can offer the same thing, and the very important feature from the blockchain is that it is immutable. So uh, all the key value storage values in a time series format. For example, suppose uh, we want to store stock prices on the blockchain. So what happens is for the stock prices, I mean, there are only few entities who can write these stock prices. One is the exchange. For example, in case of India, NSE and BSE only can write the values of the stock prices. They are the only authority who can decide. I mean, who are allowed to modify or write the values. I mean, the right access for the those values are only to them, and others are just plain subscribers. So in that case, your data gets pushed like every second, or half of a second of the duration, and it will be like endless time series data of the stock prices. So we'll be seeing how that can be managed and implemented on the multi-chain. So that particular key value storage provided by the multi-chain is called as a stream. And finally, we'll be seeing how round robin mining is actually executed on the multi-chain. All right. So what I've done is, I mean, to make it very easy for you guys to set up multi-chain and start with developing an application on top of it. I have created a Docker project for this. So my project is available at the first URL that is mentioned here. So I'll be showing what exactly is there in the project. So to use that project, I mean, you have to first check out that Git repo. I think it is already checked out in the last session. So inside that, I have created another directory and where the Docker project is there. So to use Docker, obviously you have to install Docker first and configure it to, you know, to get started on your machine first. If you are using Windows, and there is a different procedure. For Linux, it is fairly simple. All right. Then in the repo, I have created a multi-chain directory, uh, and inside that I have kept the Docker project. After that, you just have to follow the readme.md of that directory, and all the steps are provided in that. So we'll be going each and every step today in practical, and I'll be showing you how to exactly start it and how to configure it, how to check the applications and the things that I've done in the Docker project. Then there comes the CLI for the multi-chain. So there is a good example of I mean how to get started with multi-chain. So multi-chain itself, sorry, I've done a very good example of the steps to get started with multi-chain. So we'll be using their own page just because it is fairly simple and very interactive page. So whatever commands we need to fire, whatever steps we need to do, so they have documented very well. And based on the steps, I mean, we need some inputs at some steps which are unique for each and every one. So I cannot document like plain steps, but those steps should be like, I mean, those are some of the steps are like dynamic, where some values are dynamic. So we'll be seeing how this page is helpful for us. And finally, I mean, once this session ends, I mean, you can go to the API reference on the multi-chain and see how apps can be, built on top of it. Even if I'm showing an app in the demo, that is also built on the same APIs. So you can figure out like what applications, I mean, what application actually requires from the blockchain to, build your own use case and your own functionalities in the application. Okay, so let's head with the live demo. Okay, all right. So this is the Docker project that I was talking about. So this is my repo, blockchain training, and inside that I've created this new directory. Is the font size clearly visible to you guys? Or should I increase it? Well, I'll increase it. Okay. So in the README, you can see all the steps. So first you need to install Docker on your host machine, and then there is fairly simple steps. So if you guys know the Docker, I mean how exactly it works and all, that would be much better if to understand this. And otherwise, if you don't, you can just follow simple Docker tutorials and get understanding of what I've done here. So I've created two important files for a Docker project. So my first file is Docker file, no extension, just named it as Docker file. So in that, I have to just say that from where I want to, build my image or the container. So I'll be saying that from the Ubuntu's NALA 16.04 image would be my base image. Then I'll be simply running all the commands that I want to, install as a dependencies for my application or the exact application that I'm building in the image. So these are a few things like basic locals, get and curl, then wget and a nano editor and everything that is required. Then I'll be installing Apache 2, PHP and few dependencies for the PHP. Then I'm setting the locales here. Okay, after that what I'm doing is I'm just creating a directory called as opt/multichain, which is actually mapped to my project root. Okay, so we'll be seeing how this works. I'll be showing the actual VM in which I've created this image. So workdir command is simply just saying that where I want to execute next set of commands. So I'm just going in that directory. What I'm saying is that just simply fetch this package from multichain, which is multichain version 104. Then simply unpack it and set the work directory to unpack folder, and then simply move this binaries like multichain d, multichain cli, and multichain util to my bash directory. Okay, post that I'll be showing you the application that I talked about, like a web application which is built on top of multichain. So I already have installed Apache 2, so I'm just cloning this multichain web demo from the Git repo. Again, this is from multichain, and I'm simply extracting it there in the web folder of my Apache 2. Then there is something called as multichain explorer. So these are the steps associated with it. It's a Python-based application, so I'll be installing first all the dependencies, then I'm fetching this multi-chain explorer project, and finally just setting it up using its own command. So I'll be sharing these links from where this project comes from. So these are all from multi-chain, you can see multi-chain web demo and multi-chain explorer. So these are all provided by multi-chain, and again this is multi-chain core. Okay, so this is there in my Docker file. So any questions, guys, as of now?
So, Kaka, which language did you execute all these queries?
Yeah, so this is a Docker file. So Docker has its own set of commands. You can use it in Docker file. So this from run maintainer and all these commands are from Docker itself. But after run, I can run the plain command that I'll be usually running in my Ubuntu. So you can see after run, all my commands are for the are basically the Linux commands that you generally can run in any Ubuntu environment.
Okay. So at last you are running it in Python to set it up in Python, right?
Mm-hmm.
That you can use the Python language.
Yeah, I mean you can install. So this Docker, what actually Docker creates you, it's a virtual image for your application, but it will be much similar to what we do when we create simple virtual machines using VirtualBox, and there is another from Microsoft workstation or something. So what actually Docker does is it creates the same isolated environment, but not as a complete VM. So it will be on your host machine, but you don't require like all the virtualized environment for that. So that is the beauty of Docker, how quickly and how precisely it creates a VM for you, but it is simple a process in your host machine, and nothing like a completely setup of a virtual machine, I would like to say. Okay, so we'll be seeing
The
how
reason,
this. Yeah.
yeah, the reason I was asking all this question is like if I have to learn start with a
Mhm.
language
Yeah.
to execute. So then should I be if I am on Java platform or if I am
Mhm.
on Python? So for both of them it will work. For any of the languages it will work. This Docker file. Initially I
Exactly.
have to
I
go through
mean,
Docker file, and then at the last command where you are running it Python, I have to run it in Java or wherever my intended
exactly.
language
I
is.
mean, you can host any programming language application inside your Docker image. There is no limitation for that. I mean, you can install all the dependencies. Like for Java, you need to have JDK and Tomcat installed first, and then you can deploy your WAR file of your Java web application into the Tomcat. So that will also run.
Okay, sure. Thanks.
Yeah. So there is another supporting file which would be like a main file again for Docker. So that is called as Docker compose .yml file. So what this file does is that this actually controls your Docker containers. So when this will be run, the first command which builds the Docker image is done by this Docker file. After that, whenever you run your image, suppose now you have built your image and it is sealed, all the dependencies are installed, all the softwares are installed. Post that, what will you do is you will be simply running your switched off image just to start it. So this file comes in picture. So what it does is it basically asks you uh, like how many nodes or how many images that you want to create. So that is listed under services. So in the service, I would say get me a node one. Okay. Uh, to build my node, just use my root directory. Suppose you have checked out some application here, some code here, and you want to map it to the image. So everything that is there in the multi-chain directory will be mapped to my image. We'll be seeing how that works. Then you have the volumes. Volumes is again like your current directory and where exactly you want to map in the image. So so inside my image, I'll be saying that under OPT, just create a multi-chain directory and map everything from here to there. Then there is a startup command you can pass to the image. So what I have passed here is that you'll be seeing OPT multi-chain start.sh. So this start.sh is basically here in my root directory. This is sh file with execution permission. And what I have done in that is I'm simply saying that hey, when this image start, just restart my Apache 2 so that I can access the port 80 application. And after that, I'm just saying that tail dash f and anything. That means just keep the terminal open so that I can access it. Okay. Then there comes the port mapping. So what I'm saying is, uh, so this is host and this is the container. So from the container, port 80 would be mapped to my host machine's 8001 port. So whatever application running inside the container, so inside container I don't have any desktop installed, so there is no browser to browse my applications. So what we usually do is we just tunnel the ports from container to host machine. So on the host machine, you can access port 8001 and whatever application running on port 80 inside your container, you can access it simply. Similarly, for these ports, 2750 would be mapped to 2751 on the node 1. So this will build my node 1. So I'm creating another node because we are learning blockchain application. So, and it's distributed, we need multiple nodes. You can create any number of nodes right here. You can create node 3 and you can give the same configurations, and you can just start also as many nodes as you wish to do. Okay, so in the node 2, the only difference is that since on my host machine it's a single machine, my port 8001 is already bound to this node 180. So what I'll do is I'll say that for node 2 just map it to my 8002. Okay, and for again for node 2 2750 just map it to my 2752, so that it will be so there will not be any overlap for the node for the ports, and I can differentiate between which node I'm accessing and which node I'm looking at. Okay, so Docker is very interesting technology. You can kickstart within a day or two because it's fairly simple, and configurations are also simple and easy to understand. There is no complexity as such. If you know what is like how virtualization works, or even if you don't know about it, I mean, you can just start with it and try to understand how exactly this environments are getting created and how you see a completely isolated environment for your application. So suppose I want to transfer my image, or I want to transfer, or I want to share my image with you guys. So what I'll do is I'll simply send you these two files. These two files are enough for you guys just to start the same environment that I built here on my machine. And if you run this, I mean, these two files on your machine, it will be creating exactly similar environment for you guys, because everything is configured in this file. What needs to be installed, what versions you want to install, you can configure each and everything, each and every piece of uh, dependency for your application. And again, your application is definitely should be the same that I'm accessing. So any doubts up until this? Okay, so let's start with the actual practical of today. Okay, so what I've done is I've created one host machine here because I'm on the Mac already, Mac OS. So I needed some pure Linux environment because I won't bother my host Mac OS with all this, because I anyway need some pure Linux environment, because in some cases Mac has some different differences in the commands, so I usually prefer Linux for programming, and Mac OS just to keep my files there. All right.
So
So
KK, one quick question. So this
Mhm.
Docker image will work on Windows as well, right?
Yes, yes, it will be working on Windows as well. Same.
Okay. 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 Thank you.
So on Windows again, I mean, you can simply run the same Docker file and Docker Compose file, and it will create, Linux environments for you guys. No issues with that. Okay. So let's see what is there. So this is my uh, directory. I have Docker Compose, YML file, Docker file, and then I have this README files and the start.sh file. Okay. So the first command that you need to run is Docker Compose build. So this command will download all the dependencies that we have defined in the Docker file, and it will install it. And it will do all the steps right from first to end that we have defined in the Docker file. So I have already run this command just because it takes some time to download, and again the network bandwidth is included in that. So I've just already run it. So the next command that we need to run is simply say docker compose up. So now my images are built. So how to check if my images are built or not? So there is a command you can simply say docker ps all. Okay. So you can see these are all the images that I have built on my machine. So uh, even you also would come to know what these images are once you know build. So on the final, on the top, you can see that these are the latest images that I have built. So multi-chain node 2 and multi-chain node 1. So these are the two images that are very latest in my machine. Okay, so if you want to see what all images currently running, so if you simply say docker ps, it will show the list of images that are running. So currently there is no image actively running on my machine, but images are built and they are present. I can run them anytime. Okay. So one more thing about Docker Compose. The Docker Compose actually works based on your directory. Okay. So now this Docker Compose file is there in my multi-chain folder. Okay. So the images that I have built are basically specific to my directory. Okay, suppose something goes wrong and I just want to scrap this images and start a new one. So I can just copy the directory, just name it to something like multi-chain new, and just run again Docker Compose build. It will build fresh images for me. So that's how it works. So it keeps you isolated again with the directories, and that's only for the Docker Compose, because Docker Compose is specially designed for directory specific projects, so that you can simply copy it and rename it to some other directory name. So that will create another isolated image for you. So if you see, so this node 1 comes from my Docker Compose YML file. So this node 1, okay, and there is node 2 again here. So you will see two images. Multi-chain is my directory name, and node 1 is my image name that I have defined. So similarly, multi-chain underscore node 2. Okay, so my images are built. So I just have to simply say docker compose up. So what it will do is it will start your nodes or the images that are already created by the build command. And now you will see it is giving me output specific to my node. Okay, so you can see node 2 hyphen 1 again node, and this is node 1 hyphen 1. So what happens is that you can define, I mean, there is an advanced level of Docker again where you can define uh, number of workers for the Docker image. So you can, internally again create multiple images or the worker processes for the Docker image. So that is why you are seeing another postfix here, node 2 dash underscore 1. So right now I have only one process inside that. So it is saying that simply underscore 1 for both the nodes. So these are like Docker related things, but I'm just explaining just so that you guys are not confused about it. So we are having only two nodes, the images running right now. One is shown in the yellow color, and another one is in slightly blue color. And this output you are seeing here is because I've written that command there, that is there in my start.sh. So when this is executed, it is giving me a message saying that, hey, Apache 2 could not be reliably determine the server name because I have not changed the. This is a simple warning from the Apache that fully qualified domain name is not present. So that is fine. I can just simply access it from the localhost domain name. And this is because the second command saying that anything is not directory because it is definitely not there. So I just kept it just to keep the terminal open. Okay. So now just jump on to another tab here, and now just say docker ps. Now you will be seeing I am having two images of the containers running. So this is my multi-chain node 1, and this is this one. This is node 1 and this is node 2. And we will be seeing all the mappings that I have done. So all the mappings in Docker Compose YML, you can see it again here. Port 80 and the port 2750 is mapping here. Okay, so my images are running. So I've listed all these useful commands here. Again, whatever are necessary for our project. So my images are running now, but how to access those nodes now? I mean, I know that my nodes are running, but how to go inside that node and how to run commands and how to check the application. So for that, what you need to do is for node 1, just copy the container ID from here and simply say docker exec command, which has this format, and say I need to start with the bash command or the bash program for the from this particular image which is running already. So connect me to the bash. Okay, so now you are inside the image with the root user. Okay, and the directory that I'm landed on is opt/multichain, which I had created in the Docker setup. So now just check what is there. So here again you can see the same thing. My same project has come here, and I can see all my files here. So similarly, connect to node 2. Okay, just go to node 2's container ID. And you are inside the node 2. So now how to check the IP addresses of these nodes? So simply say so I can see the IP address for my node 1 is 172.19.02, and for the second one I can see it is 172.19.03. So that is fine. And again, just have a check whether I can communicate between these nodes, because for running multi-chain, you need to be on the same network or the reachable network. So let us ping that guy from node 2. Yeah, and you are able to connect with him. So right now you can see I'm into completely isolated environment where my host machine is different, and I'm into another image which is again a Ubuntu image, but a isolated one. I have different IP address. I have all the everything is different here. I mean, there is nothing. Uh, I mean, I would like to say shared from your host machine. You have a completely isolated environment, like a fresh virtual box, a virtual machine. So that's the same thing, but this is from the Docker. So we are into node 1 now. Okay, so after this, what I'll do is I'll start with the actual page, which is an official page by multi-chain, which is very useful and well documented one. So we'll start with the steps that are provided there. Anyway, I have documented this on my README file, but we'll see why this is very useful. Okay, so right now we are in the node 1, and but there is nothing kick-started here. I am into just fresh node where my multi-chain is installed. How it is installed? Because I have done that from the Docker file already. So if you see, I have already moved these commands to my bash. So let's see whether it works or not. So before that, let's jump on to CLI command. So CLI is multi-chain's command line interface. So let's see whether it is available. Yes, it is available. Okay, so it is installed and ready for use now. So let's follow the steps to basically create a chain, so or a blockchain, I would say. So my platform is ready, multi-chain is ready, but I have to kickstart a new blockchain. Okay, so I would name my new blockchain as say chain 1, and to create that chain 1, you have to run this command. See, it will show you that your blockchain has been created successfully, and the parameters file for the blockchain is located here. Root slash dot multi-chain chain 1. Chain 1 is the name of the chain that I'm giving here. So if you say chain X, then chain X would come here. So what multi-chain does is that, uh, Sunil might have already told you that multi-chain can run, as the name already suggests what it is. It can run multiple chains or blockchains at the same time on a same platform. So that's the beauty of multi-chain. So I can create as many chains as I want, and I can simply name it accordingly. Okay, so chain name is unique. So I've started chain 1 right now. And what it says is that to generate the blockchain, to generate the first genesis block for the blockchain, just run this command. So I would simply run it. Okay, fine. So what it says that okay, so this gives me some information about the platform, that is multi-chain 104. This is the protocol version, and it has now started the Genesis block. Genesis block is found, and it says that other nodes can connect to this node using this connection. So if you see what this connection is all about, this says that multi-chain D is a command for multi-chain, and this is chain 1, and at the rate the IP of my node where I started it, and the port number. Okay, so anyone in the network who wants to connect to me just have to run this command on his multi-chains instance. Okay, so now you would say that so again this has become public, anyone can join me, but no, this is not the case. It is just a connection string, but after that uh, the administrator of the node 1, this Genesis or the root node, has to approve and give permissions to the node who is trying to connect to me. We'll see that how that is done. Okay, so we have run these two commands for now. So now I was saying that this page is very useful because of this. So now it says that copy and paste the node address here. So let's copy that. So after that, it will do some useful things for us. So let's copy this from here. Okay. So what it does is it creates all the commands which are required for me in the future based on my address. Okay. Now it says that your blockchain is running on node 1, and so let's connect this blockchain from somewhere else. So I have a node 2 already running. Yes, I can connect from there. So it says that from the second server, just copy this same command, and this is the same one that already given by this multi-chain. Okay, so I'm on node 2. Simply say just connect to this guy. Okay, what it says is that retrieving blockchain parameters from the seed, which is the node 1. Okay, blockchain successfully initialized. That means now this node is attached to the peer-to-peer network of the chain 1, because I had pointed chain 1 on this IP. Okay. Now it says that please ask the blockchain admin or the user having activate permission to let you connect to and or transact. That means I have initialized the blockchain. I got the parameters from the blockchain, where it is located and where the port is. But to actually participate in that blockchain or the that private network, I would say, because this is something that we are doing on a private network. So this is not a public network I have exposed to on the internet. This is something that I'm doing on my intranet. Okay, or some network which is owned by me, because I'm utilizing the network bandwidth and all, and I'll be utilizing that for my custom application. Okay, so now it says that provide these commands to the admin of the blockchain. That means the node 1. Okay, who has actually kickstarted the chain 1. Okay. So it says that just give him these commands to run, and you will be seeing there is some common thing here, which is this particular unique address. Okay, so this is a unique address of node 2. So what it is saying that multi-chain CLI chain 1 grant connect access, and then again grant connect and send receive access. Okay, so now this guy cannot run it because the this has to be run on the actual root node. Okay, so let's copy these two things.
Yes, Sunil, these two things are not clear. Could you
Yeah.
repeat once? Multi-chain CLI chain 1 grant. After that string, that is not clear. So what does this represent?
Yeah. So this unique string is basically an address of the node 2. Okay. So
You mean the IP versus port that is different from this one now?
not the address, but the address on the blockchain. If you remember, when you send some ethers to your friend,
Public
so
key.
he had some address, right?
This is public key.
Yeah. So this is associated with his public key, and this is his public address on the network, on the blockchain network, not the TCP network. Clear?
Address of home, admin you mean?
No. This is the node
Address of
2.
node.
Node 2, yeah, because I am on the node
Okay.
2. I tried to connect to node 1, and it says that it is initialized, but you have to pass these things to the owner of the blockchain so that you will get access to it. Okay,
Okay.
fine. So I will copy these things. So that means how this will be working in a real world. So you must be knowing a person or an entity or an organization to whom you're connecting. So suppose tomorrow you are starting a blockchain. So I should be knowing you personally, or I should be uh, within your organization, so that I can send this thing. Hey, Sunil, just allow me to participate in your blockchain. Got it? So that's
Okay.
how it is. Different from the other blockchain which are public, but this one is totally private and secure. So I'm just running these commands on the node 1 now. So it says that it is done, and it has given me the transaction number as well. Okay, the second command. Fine, both of the things are done. So now I have access, I mean the node 2 is having access on the chain 1, which was kickstarted by node 1. Okay, so now that's fine. So now you should be told that it was successfully initialized, and so this is the page that I was talking about. So if we just copy this, even if we have already run it, but just see how it creates some useful commands for you. So this actually replaced this address from here, this text box, and created a command for you. So this we already run on the first server, so that is fine. So now try reconnecting again from the second server. Okay, so to connect to the blockchain and become a part or become an active participant at the time and start mining and everything. So what you have to do is simply say, so the chain 1 is again now, because I have initialized chain 1 which is located on node 1. So this chain 1 is again specific, and start the daemon. And what it says that the node is started. Okay, the blockchain parameters are retrieved, and the listening for the API request is on port. This is something that I'll show you later, and it says that node is ready. So my node is now connected to node 2 is now properly connected with permissions to the node 1's blockchain. All right. So now before we proceed, let's interact with the blockchain. So uh, I know that I have allowed node 2 to connect to my blockchain, and he is a part of my network and everything. Okay. So just go to any server, I mean any node. Let's run this on the, let's enter into the CLI mode now. So CLI mode is something that this is like a Python shell. If you know what Python shell is, or what Python command does is inside, I mean Python shell, you can run all the Python commands, and you can simply write your Python program as well. So similarly, there are some specific commands to there are some commands which are specifically from the multi-chain. So to run those, you have the CLI interface, and you are now connected to your node 1, because I ran this on the node 1. So there are some informational commands like get info to check the information about your node. So it will show you things like this, like version, node version, what is the protocol, the chain name, and you can see because I am connected to chain 1, it is showing me specifically about the chain 1. So this CLI, you can CLI command is specifically takes an argument as the chain name. So if you have a chain X or chain Y, you can enter it here, and you will be seeing the information about the chain that you connected to. So this is my chain name. Okay, protocol is again multi-chain. This is the port number, and there are various parameters about this which are specific to the multi-chain. So you can see all what are all this on their reference page. So all these are very technical things, but we'll be coming to the web interface as well. So all these are very technical information, but as and when we enter into the web interface, these things are not needed to deep dive into right now. Okay, so we can check all the permissions which are given to the chain 1. So let's see these permissions. Okay, so here I can see what are the permissions given to. So you will be seeing one address which is repeated in almost all of them, but there are some entries for second address there. So this address you are seeing is basically the address of this self node. I mean this node one itself. So the starter of the multi-chain has all the rights because he is the, I mean, the father of the node. So he has all the permissions and access rights to that. So this is the permission type you can see. So the mining permission is given to me. This is admin permission. This is activate permission. This is connect permission, send, receive, issue, and you can see these three entries at the bottom are specifically for the address, which is you can validate and see this is for the node 2. Okay, so when we had actually run these commands, so these permissions were given to this guy, which is my node 2. So this way you can always browse what are the permissions given to guys. And definitely, I mean, by looking at this address, you should be able to determine who is this guy because you have added it, so you must be knowing it. You must have written somewhere in your personal email or some Excel sheet about this address mapping. So when I say this address, so you must be knowing that hey, this is some machine on my network. I know that. So like that. I mean the real world management is up to you guys because the address on the network does not identify anyone in the real world. Okay, so then there are multiple commands like get new address. So this will create another address for you. So how this is done? Because yeah, I mean on the network I can create multiple addresses because I can that just a public key associated with my account. So it is simply like creating another account on my node. So that doesn't matter. We'll be seeing this in the live web application. So let's just jump to another command like we can list all the addresses. Okay, so this shows me my address. So I have only one address right now. That's fine. And this says that get the blockchain parameters associated and written in this particular file. This file is pretty much important file for the blockchain's complete life cycle, I would like to say, or the it basically defines the behavior and the attributes of your complete blockchain. So what are the I mean we'll be looking at this file specifically into the editor, but there is a command for that which can show you the content. Yeah, so yesterday if you guys remember, Sunil must have told you about the uh, few things from this file, like the difficulty and all. Then there is something called as diversity level. So all these things are written here. For example, this one, mining diversity. So this comes into picture for the round robin mining. Uh, and this is again a complete different aspect we'll be looking at the end of this session. So there's some parameters which are very important from this file. We'll be looking at this in the editor again. But yeah, I mean, this is the file. You can access it from the file system and from the command as well. Okay, then there is one more command here like get peer info, which will show you all the connected nodes to you right now. So it says that, yeah, this says that this is the person who is connected to me. Okay, this is my local address. This is the local address on the blockchain. This is network address. I mean the TCP network address, and this is the blockchain address. And this is the guy who connected to me. So currently in the array, you can see this is JSON, and it is an array. So currently there is one guy connected to me, that is this person. Okay, so I mean that's how it is. I mean you can just you can anytime jump into the CLI and see the information about your or the status of your blockchain. So let's jump on to the actual use case. Like now this is set up and this is running, but what is the use of this? Okay, so here comes the another thing in the multi-chain that is called as asset. Okay, so asset is something that is represented in the data. Okay, so asset means a data that is I'm treating as an asset. So it can be anything. It can be a coin. It can be uh, a land record. It can be a file. Anything which is which I can fit into a size of maximum allowed size is 64 MB. So within 64 MB, whatever you can fit will be called as your asset. So that is my asset. So let's say that I would be creating. Let's take a simple example of coin again, because we'll start from the coin and we'll jump to the other type of assets or things from the web interface. Okay. So now it says that to issue. So how this asset actually starts? Okay, so there is a permission called as issue. You might have seen that when I showed you the permissions list. Okay, so in this you can see there is one. Oh, yeah, so this is the permission which is called as the issue permission. So issue permission means that you have a permission to issue an asset, a new asset. Okay, fine. So just check the list permissions, and in that, let's see the issue permission. Okay, so it says that only one guy is having the issue permission, and that is me. I mean, that is the same node, so that's fine. So just copy this address and paste it here. Now what it says that now we'll be creating an asset on this node with some limits. Okay, so for example, I'm creating say I'm creating a coin again here, a currency coin. Okay, so just jump here. Suppose I want to create 1 million coins. Fine, and the denomination again. Okay, so this is the quantity. I'll name it some different way. So I would say that this is my MCX coin, or I can name it anything. This is a string. As I said, this can be a 64 MB maximum allowed string. You can pass it here, uh, and that can be your, that you can treat as your asset. For example, I can say that this is coming to Sunil's the legacy example. So I can say that this is uh, ABC apartment flat A10, sorry, A101. Okay, so Sunil, so in your case, when you say that I want to create an application, or I want to put the land records on the blockchain, so in that case, I would be saying that this is the flat number A01 in ABC apartment. Okay, and I want to maintain that on the blockchain. So just create one quantity of it, because obviously the real flat would be one in the world, and this denomination would be again one. So whenever this is uh, created, that means we are creating or we are issuing this flat, or I mean we are putting this flat on the blockchain for this guy. So this guy means I'm the owner right now of this blockchain. So once if I execute this one, so this will create one flat with this name, and the owner will be this, or the current holder of this asset would be this guy.
And what about the details? Where will we pass?
Yeah, so I
BHK to
can,
BHK.
yeah, exactly. I can show you that in the web interface. So in the command line, I mean, I don't have the complete JSON in hand right now to create that. Okay, so I will be showing you that in the web interface. So let's simply go with the MCX coin again.
Kaka, one question, again a
Yeah,
basic question. So when this Bitcoin would have been started by Satoshi, he would have done this thing, right?
exactly. So when he kickstarted Bitcoin,
Mm-hmm.
he would have done this thing. So he would have created the coin called as BTC. Okay, here,
Mm-hmm.
and this would be the first address. I mean, definitely his own address, and
Mm-hmm.
the amount of coins that he initially, started.
Okay. Yes. Thank you.
Okay, so let's create this asset. So it says that it is uh, put on the network and transaction number is there. So my asset is created now. All right. So now let's see balances. So now it shows that here are your assets, and this is the one asset that is there on the chain right now, which is CMX, and the quantity is this. That is fine. Now let's say I want to transfer this asset to the person on the network, or the node on the network. Okay, because that's why the blockchain is present to transact. Okay, so if you notice here, this is already an address of the second node. Okay, this was the second node. So this page actually creates all these interactive commands for you so that it goes very smooth. So this is the address of the second guy, and it says that send asset, because since I'm the owner of this asset and I'm running it on node 2, it will execute. Same would not be executing on the node, I mean the other node, because he doesn't have any quantity or uh, any asset associated right now in his balances. Okay, so send, just change this asset one because we modified it here only. So CMX is my coin, and say I'm just sending some 100 coins to the other guy. It says it is on the network. This is your transaction ID. Fine. So now let's again check the balances, and let's see whether it is executed or not. Yeah, it is executed. The balance is reflected. Okay. So let's see and check the whether it is actually delivered to this guy or not.
Hey, Kaka,
So
is there means can we connect through MetaMask to these nodes?
no, MetaMask is associated with Ethereum platform, right? So that is
So is
another
there
different.
some GUI type client basically from where we can
Yes, yes.
connect these?
Yeah, I'll be showing you that. So when I'm
Okay,
talking like web interface in my whole session, I'm talking
okay,
about that complete interface which has all these things. I'm just showing you these commands because if you want to develop an application in future, okay, so you
yeah, we
must
need
be
this.
knowing all, yeah, so you must be knowing all these commands, so which you need to, code in your application so that you can communicate with the multi-chain.
Yeah, correct.
So all these are available in the APIs. The commands are same, but this is command line interface, and in other cases it will be REST API.
Okay.
Okay, so let's see on the node 2 whether I have received it or not. Okay, so jump on the command line interface on the node 2 and see balances. Yeah, so here it says that I have 100 CMX coins in my balance. Fine. Okay, so this is again a permission command. So this is saying that I mean right now I have given the permission send and receive to the second guy. So that is fine. This is again saying that they granting the permission. If it gives you some error, then grant this permission. I mean in future suppose permission is revoked and I'm not able to do that, so I can just grant it again from here. Okay, so you can again see what are the transactions on my wallet using this command, that is list wallet transactions. Okay, so let's run it on both the nodes. First on the node 2. So node 2 there is only one transaction as of now, which is for the asset named as CMX and the quantity was 100. So that's fine. It says that this was transferred to my address, which is same my address, and the incoming address for this guy. So this is node 1 who sent me this 100 coins. So that's fine. So I'm able to see transactions. And you can again run the same command on the node 1 to see transactions that I executed. Okay. So here it says, here it will show you the same thing, but this is minus quantity. That means it is deducted from my own wallet. Asset was CMX, and this is my address, and this was the address to whom I sent it. So fine, everything is pretty much visible and transparent to the network. And these commands like list wallet transactions are publicly, these are by default available to all the nodes who are connected. Even if they don't have the right access or the right permissions, they have these read-only permissions with them to see the transactions. Okay. Now I can again check the metadata associated with the transaction as I the send with data command thing. So this was the thing I was talking about, Sunil. So I can send an asset with a JSON here. Okay, if you are looking at this, so this is a JSON I can form. Like in your case, you said that what is the wing number, what is the address, what is the pin code, right? So we'll be coming to that part in the web interface, because in the command line it is will not be clearly understandable as of now. Okay, so now let's come to something called as streams. So before jumping on to the streams, I think it's time to jump on the web interface. Yeah, because it is going too much on the command line. All right, so we'll jump on the web interface right now. Okay. So if you remember, I had configured the web interface that was here. So in my Docker file, if you see, I'm installing this Apache 2. So whenever you install Apache 2, the by default configuration is to start on port 80. So yeah, so in port 80, it will start my Apache's default website, which is located at var www.html. So inside that, what I had done is I had installed this multi-chain web demo application or the web app. So this is in. So whenever I'm saying work directory in the Docker, that means command after this would be executed on this directory. So git clone has executed inside this. That means I'll be having uh, a directory inside I mean the web root, which is called as web chain web demo. Okay, so let's go to host machine. So this is my host machine. So now if I see, I'll open two tabs here just to show you what I'm doing. Okay, so this 8001 is mapped to node 1's port 80. Okay, and 8002 is mapped to node 2's port 80. That's fine. So inside that, my application is here, multi-chain web demo. That's fine. So I'm now able to see the multi-chains web interface. Fine. But if you notice, let's open it here again. Fine. So I'm able to connect to both the nodes web interface. Fine. But there is nothing here. So why it is that? Because I have not configured my web application to connect to my uh, chain instance. Okay. So let's do that. So there are steps I have already written here. So right now we are running this command on both the nodes and we are at this step now. So let's go to node first. Let's fix the web interface or let's start the web interface on node 1 first. So remember this chain 1 is the yeah. So this chain 1 is the name that I've given to my chain. So this is a dynamic, just remember about it. So now let's go to node 1 and open the parameters file for the blockchain chain 1. Okay, so I'm on node 1. So exit from the CLI now. Okay, you are back to the bash and now let's open the parameters file. Okay, so you will be seeing all the information that I showed you in this CLI command as well. So all the information is here again. So these are the parameters for configuration of your blockchain. And some of the important one I'll be showing you here is you can see this is that anyone can connect false, anyone can send false, anyone can receive false. That means this is predefined configured as a private blockchain. Okay, because the permissions now have to be given manually to each and every node that is that I want to include in my network. So that's how this is private. I mean, in case of Bitcoin and Ethereum, these are kept open, so anyone who is knowing the address simply can join it, or anyone who knows the network connection string can simply join the peer-to-peer network. Even if I know the one node in the network, I can join in. That means I am connected to whole network. So, but in multi-chain, you have this pre-configured thing because this is specifically created for private blockchains. So that's why you can see all the permissions are given as false by default. Okay. So then come down and we want to select few things from here. I want to note down few things. So in my step, I have written that just copy the RPC port value for the default RPC port. Okay. So from this, you can see there is something called as default RPC port, and this is where my APIs would be hitting. So right now my web interface is not able to communicate with the blockchain instance because I mean the web interface does not know where it is hosted. The port is not known to web interface. So let's copy this number 4258. All right. Now let's open the multichain.conf file here. But before, okay, that's fine. So this was the previous file was the parameters file, and this is configuration file for the, and there are very limited things given in the configuration file. We'll be seeing what is there inside that. Okay, and it says that RPC user and RPC password. Okay, so RPC means remote procedure call. So if my application wants to communicate with the multi-chain instance, I mean the application should be knowing these credentials to communicate with. So it is very similar to like the APIs that we connect to, like Google's APIs or Amazon's APIs. So we get a access key or some credential file to communicate with it, or some access token. So in a simpler way, they have given this username and password. So that's fine. So what we have to do here is we just have to paste or append a new entry here, which is called as RPC port, and RPC port and the same port, that is 4258 here. Okay, and simply save this file and also copy the password in this file because we require it in the next step. So let's close this file. Okay. So we have done this. We copy the RPC user and the password. Okay, and now go to the web demo project that is present in webroot. Fine. So let's go to webroot. And you will be seeing I have already checked out the web application here. Okay, so if you see the files of this web application, this is plain PHP application which we just saw it here. Okay, so what they have done is they have given some uh, sample configuration file. So we have to the example configuration file to something called as config.txt. So let's do that. cp config example to okay, and then edit that new file. All right, so now you will be saying that what are the entries here. So this is the name of the chain that I want to, or I can just simply change to what exactly the name that I've given, that is chain 1, and this is host, my localhost. RPC port is something that I have to replace here, that is 4258, and this username, you will be noticing that this was the same username there, but the password that I had copied, I have to paste it here. Okay, I pasted the password. So I'm done with this configuration. Simply say save and exit. Okay. All right. So I'm done with configuration, at least on node 1. So now let's browse the node 1's web demo project. Yeah, and you see that I'm seeing chain 1 now. So let's open chain 1. All right. So now I am able to see the web interface for my chain 1. Okay. So we'll be saying this is node information, which says that this is chain 1 version protocol. Again, the
Kata,
nodes. Yeah.
could you go on second tab? I mean, on the browser itself.
Yeah, because it will not
You
show you
clicked.
because I'm not.
No, just okay. So on the
Yeah.
multi-chain demo, you clicked after the config change, and we get all those data. Could you show
Yeah.
the corresponding PHP file?
Yeah, PHP files are here. I can just show it to you.
Basically, Yeah,
These are
obviously
the
getting all the details from config file and then querying from
yeah, these
multi-chain.
are the files. Yeah, I can just
Let's
quickly show you that. Okay, so this file that we are seeing here is okay. I mean, this is a PHP application. You can the link is there. You can anyway check that. But if you say,
okay.
I'll just quickly open it and close. Say this. Okay, so it basically reads that configuration from the config.txt file that we created, and based on that, it communicates with the uh, blockchain's APIs that we saw
Yeah,
in the
yeah.
CLI.
That part I want to see basically.
Hmm.
After reading the config file, what it's doing, calling the REST API or something.
Exactly. Yeah. Okay. So I think I've done on the node 1, but let's do it on the node 2 so that we'll be seeing the interaction on the web interface. So let's jump on the node 2, exit from the CLI. Okay. Let's repeat the same steps. Okay, just okay. So let's go to the port. Yeah, port is same. That is fine. Sometimes the configurations get created different, but sometimes they're fine to have because it's a machine related port. We are fine with it. No issues to have same port there because it is only related to web application and the blockchain instance within the same machine, so that's fine. Okay, so let's create this entry here. RPC port equals to 4258 and save it and close it. Okay, I forgot to copy the password. Password is different, yeah. So let's copy it. Now jump to web application and copy the config file. So here again the same application. So let's change the port. Let's paste the password. Save, close. Okay, I'm done. So now let's open. We forgot something. We just keep the name default. So this is again regarding the chain one that I'm connected. Okay, now let's go to tab 2 and see. You get a chain one again here. Now you can differentiate these two nodes. You can see the address, network address is different. See, this is 0.2 and this is 0.3. So you get the information how many blocks are there, how many PS are connected. Okay, so you will see that to this particular node, 03 is connected to it, and this is his handshake address. Handshake address means again the same address on the blockchain, which is associated with the public key. And to node 2, node 1 is connected, which is 02, and this is his address. Okay, fine. So I get some basic information here. This is my address. I can name it to my address. This is simple label, nothing to worry about it. My address. So this is again goes into transaction, and once it is done, we will be seeing it here. So every data change or every uh, piece of data which is changed on a node goes on the network, and that is again as a transaction. So that means it has to be validated, and uh, the authenticity of the change. That means if I am modifying it using my own private key. So here comes the private key in picture. So since I'm modifying it, my private key will be used for that. Okay, and all the nodes on the network will be validating that transaction using my public key. So since my public key is public to everyone, they can try to decode that transaction, and if it is decoded successfully, that means this was done by me. I mean the owner of the account. So that is how it is done in a very simpler way. Okay, so I can manage these two nodes specifically now. I mean, right now this is on my same machine, but in the real world, this can be, over the intranet. This can be my, uh, say, located in, say, accounts department. This is something might be there in my HR department. Whatever you design in the actual problem or actual, the real world situations. So that is how it is. I mean, right now we are in the web interface and we are seeing the basic information. So that is fine. So now let us browse this complete web interface and see. I mean, we can call this as an application itself because I'm connected to my node. I got some controls in my hand to control my node. I got few things which I can, few actions in my hand which I can do, and I can, I would say I can solve my problems. For example, I can create my asset here. I would say I would be showing all these things how to do that. Okay, so let's start with some permissions. So we'll be saying that since this is a node one who is the owner of the blockchain, he has all the permissions because this is his own address. And again, you can see this is my address. That's it. My address means the label that I change here. So let us change it to something that uh, node 2 because it is displayed to everyone so that it should be identifiable. Node 2. Okay. So let us change the label. Okay. So node 2 is having this address, the public key address, and these are the permissions we had given to the node 2. If you remember, this uh, was done by a command line that we had run previously. So is it clear as of now, guys?
Kaga, one quick question. Where we
Yeah.
generate the public key and private key in this
So
step?
this is generated automatically when a node is instantiated.
I
Okay,
see.
so that is done by the platform itself. So
Okay.
platform generates those for us because we cannot define our own private key because it's again a cryptographic key which has to be in a particular format, and which again has to be with specific length. Sorry. Okay, guys. So yeah, as I said, the public and private keys are often uncreated by platform itself because they needs to be in specific format and length because that's when the key will be secured if it is there in the predefined format. Otherwise, if we define like say a key of some random length, then it would not be fitting in the encryption algorithms, and it will basically fail on the network because it should be in a predefined format and the protocol. Okay, so this is permission stack. You can, I mean, this is not just a read-only
So
mode.
another question here.
Yeah.
So this is, since we are talking about a private network, private world. So my question is, the admin, I should be able to get the complete, I should be able to store the complete information of the node in my system somewhere, right? For example, if node 2 has asked for a permission, I should be able to get his identity if I am required.
Yeah. So yes, I got your point. But since this is private, so suppose if anyone wants to connect to you, so what he'll be doing is he'll be sending his address to you over email or some messaging platform, and based on that you can identify him, or you can create another application, basic small application in your intranet, just to submit the addresses and the identity. So that's how it works,
So
because in the real world you should be knowing the person personally, then only you can
exactly,
give him the rights.
exactly.
Because if you trust
So
him
so
yeah.
my point here is, so we need to have a separate altogether an application, and it
Not
should be
an
outside
application,
our.
I would like to say, because see, these kind of things like blockchain and all are fairly technical. Okay, so someone who is setting up must be definitely a technical guy. So if he wants to set up a node to on the network, so he will be getting the address of that node and sending you over the email. So that's how it is. I mean, there is no specific need of application as such, but I just said that it can be done.
Okay. So what you're saying is that the information about the node 2 should be maintained at a different place, somewhere else, other
Yeah,
than the
exactly.
multi-chain.
Exactly.
Okay.
Yeah, I mean, at least the identity of the node 2 is uh, should it is private again, and if he wants to be a part of network, he should come to me, and I should be knowing him in the real world. Hey, I know this is Sunil's address. So yeah, it is fairly fine to add him, right? That way. All right. So on this tab, you can again do many things. You can if you want to change the permissions or assign permissions to someone new on the network, so what you have to do is, so this will remain same. This is your own address, admin's address, and this will be the for address. For example, suppose there is a new node comes on the network and he wants to be a part of it, and you want to give some permissions to him. So just paste the address here. Right now it is showing me one of my previous setups network address, but that is not a valid on the network. So just paste the address here and just change the the selections here. So what I'll do is I'll copy this same guy, node 2. So right now you can see there are only three permissions given to him. So what I'll do is I'll paste him again here, and I'll say I'll give him new set of permissions, which includes his previous one, and I'll give him these many permissions. Okay, so just hit the change permissions. Yeah, and see it's gone to the network with this transaction, and you can see the updated permissions for node 2. So if you refresh this page, you will be seeing that his permissions are now updated. Okay, you can again copy this address and just we can say only connect and send and receive again, modify it again. Right? So let's refresh it again. Okay, sorry. What I did is I have to revoke this permission. So when saying it, okay, revoke mine issue create. Okay, revoke mine issue and create and keep this as it is. So that's fine. Just send it. Okay, that is done. And again back to the previous set of permissions with node 2. Okay, fine. So now let us come to the asset part. Okay, so you will be seeing that one asset is already listed here, which is issued asset, and you can see which is CMX. Okay, CMX is my asset issued on the network, which has total quantity of this 1 million, and these are the denominations. And issuer is again me because I had done this on the command line interface. Now let's come to send. Send button is for sending the asset. So here you can see my available balance. In the issue asset tab, we are saying it as 1 million because this is the total quantity on the network. Okay, and you can create a fresh asset again here. And sorry. So now let's create the asset that Sunil is talking about. So now let's say create ABC apartments flat 101. Okay, and the quantity is 1. Again, units say 1, and to whom I have to issue this asset. At the time of creation only I can say that, hey, let's create for the node 2. So the whole quantity will be allocated to node 2. Okay, I can do that, but let's say keep it to me for now. Let's keep the flat for me. Okay, so then you can see it here. I have this option to upload a file. Okay, so that means I can attach some file, some physical file like PDF or anything to this asset, so that whenever this asset is transacted, so the file is present there as a data associated with this particular uh, asset. Okay, so that file can again be your say agreement or whatever document is associated with your actual real asset. Okay, so and there again you have some custom fields which are like key value storage fields. So I can create suppose I can just give address to this apartment. I would say city, say Mumbai, then state. Okay, and say pin. Okay, so I can associate multiple key values to it, and this again can be, you can put the whole JSON or you can put a complete file to associate it with this asset and say issue asset. Now let's so my flat is put on the network. So this is my flat name and identity for now, and I have issued. I mean, this is the issuer. I mean, this is the one person who had issued it, and these are some of the metadata associated with the asset. Okay, so now this is issued asset which are present on the network. So if you come to send, okay, so this is just a display issue here, but this is flat ABC apartment flat 101 and the quantity is 1, but this is a CSS issue, or I think my screen is very short for this, or I guess the name that we have given is not fitting in the table. I can just show you guys. Mm, okay, you can see this is the asset name and this is the quantity. So there is one quantity of this flat which is in my position right now. Okay, so what I can do is, since I am on the send tab, I will be coming here. So from address, that is me, I will say select the asset, that is this flat, and send it to this guy, that is node 2. Okay, and I'm sending the whole flat, I mean that is quantity 1. So send asset, you can see the flat is now gone to that guy. Okay, so now come to node 2 and you can see the flat is now sold to node 2. Okay, and everything is recorded on the blockchain with these transaction numbers. So there is a I mean Explorer app which you can see what these transactions are. For example, I mean, last time we see about Robstein.
So, Kaka, in this example,
Yeah.
a centralized authority is transferring, right?
Yeah.
It is not okay.
Sorry, what is the question?
The question is like in this case, the example or use case which you just did, it is again some kind of central authority which is doing this transfer from one person to other person, right?
No, no. Actually, what is happening is I am pushing a transaction. Okay, because I was owning that flat. Okay, it was there in my wallet. I sent it on the network. Okay, so whenever I'm saying I'm sending an asset, that means the transaction is getting pushed on the network, and you might have seen a transaction ID was given to me. Okay, so what happens that transaction goes on the network. All the network nodes associated, I mean, which are present and active on the network, mines the transaction. They validate the transaction that yeah, this is the uh, valid transaction because the sender of the transaction is the actual owner, because they know my public key. If they are able to decode that using my public key, that means I had encoded, I mean, I had encrypted that using my private key. So that private key is my something that is my identity, my ownership. So uh, on the network, it is confirmed that it is only sent by the owner. Got it?
Khasa question is that who is going to give that asset key in my wallet? Is that who will go and create any flat? Definitely not.
Yeah, I mean that is again you can control on the network. You can, I mean, this asset creation mechanism permission. Okay, so right now,
So Kaka, Sunil, let me answer that. So Sunil, basically, when first time taking example of the Karnataka government itself, right? When Karnataka government will start this project full scale, first time they will register all the properties that they currently have in their current registrar database, right? So currently also they have a registrar database. They will register all of it on the blockchain that they're building. From then on, whenever someone wants to sell or someone wants to transfer ownership rights, they will do on this blockchain application.
No, okay, Nagesh, got it. So it means database and blockchain, two things you mentioned. So assuming I have
No, I'm not
101
saying you
flat.
have to. Yeah, I'm not saying you have to create a separate database. I'm saying currently
Okay, coming on the block, yeah.
Yeah,
Okay.
currently also when you go for registration, okay, they have a history of who this land belong to, okay, which is what we call as title deeds, etc., right? Which is what your lawyer does when you try to buy a flat. He will try to find out the ownership and the title ownership for the last 20, 30 years, whatever, to find out that the property is not in dispute. When you do the registration, you have a 50-page or 40-page booklet sort of registration document, which is scanned and kept at the registrar. Okay, so this document, you have a copy and the registrar also has a copy. Now, whenever you want to sell it, okay, you will produce your version of the document that, I own this property. The person who is trying to buy, okay, he will also have to do validation that you really are owner of it. He will hire a lawyer. Okay, the lawyer in turn will go to the registrar's office and try to find out who is the correct owner of this office, of that apartment or flat. With blockchain, this is no longer required, because if the asset is once loaded or created for the first time in your name, okay, then everyone on the network is able to see that you are the rightful owner, okay, and from then the transactions can be smooth. The lawyer does not need to find out who the property belongs to. If you are the buyer, okay, second buyer, then you can also be sure that Nagesh really is the owner for it. Otherwise, what happens currently is you would have seen a lot of scams wherein people claim to have the property in their name. They sell it, and then later the person find out that it did not really belong to that person. People sell government lands which have been unused for a long period. People say it is in their name and they try to sell it. So when the government puts all of this data on the blockchain, the first good thing that comes out of it, anyone can verify who the asset belongs to. Second is, no one else would be able to sell it in your name. Okay, which is what happens in remote villages, wherein without the correct owner's knowledge, someone else does the sale, they get the money, and they run away with the money, and the poor guy is in trouble. So with that, what the government is trying to solve is these scams go out, and there is an easy way for anyone to find out who is the real owner of it.
Okay, so first time basically we have to go to registrar office or lawyer or any person who has the authority to create asset ID for me and add in my wallet.
In this case, it would be the government who would be doing it anyway, because they have to track all of the properties that they have. So whatever they would be having in the current registrar, I'm hoping that is the correct way they are doing it. But in other countries, use cases that I've seen, that is how the government does. So government has land maps, area maps for everything that comes in their jurisdiction, right? They will create all of these apartments that exist currently, all of the land pieces that exist currently on the blockchain as an asset, okay, with the rightful owner. And from then, whenever you do transactions, obviously it would not be like you said.
After that it's clear. So one basic question that remains is, there are 50 scanned pages. First time creation, go for the first time creation.
Yes.
Where will be those 50 pages? In the blockchain itself or in some database? If that is in database, whether that will be distributed or not?
If you can see here, we had an option to attach a physical file. You could store it there itself. Sometimes you may not need to store even the first the entire 50 pages. Like for properties, you have something called as the index 2, which lists the owner, and it is just one page. So you could be storing that itself. Now that depends on the specific implementation that you're doing and what your business requirement or what the government thought should be stored. But it provides you with an option to store data along with the transaction.
No. Why I'm asking, because this is a basic question I have been searching for a long time. I mean, whether metadata will be stored in blocks or the whole content. If the whole content, there is a limitation of the block size that comes in picture. If whole content is not in the block, then in some database. If that is a single database, that can be easily corrupted. So if that is a distributed database where that hyperledger comes into picture. So if that is the case, your database is outside, how communication will go?
May I get your point? What I'm trying to say is, if you see, there is a 2 MB limit that we had for files. Okay. Now we that limit is also decided when you design the network. This is a private network. You can do anything that you want with it. Okay. If you want to store the 50 pages and the 50 pages comes in less than 2 MB, you can store it here, or you could just store the index 2 and you can maintain the other data at. You want to store it in a distributed database, you want to store it on the cloud, you want to store it in a private database. That design is up to you, because you are the business, you are the owner of that data.
Right, Kaka. Means this is a basic question which is getting asked. If that is a single database, then that can be easily corrupted. And using the blockchain only, we can verify that data is correct or not. If not, then where is data, right data?
Yeah,
the basic concept of blockchain is that we have to keep it safe, all the data.
exactly. I mean, in this case, as you see, I have a attachment field here. I can attach the whole agreement or whole complete document. Right now, it is configured as a 2 MB limit, but you can increase that from the configuration. And suppose you have 100 MB PDF file, which is a complete scan of your agreement or the document of your property. So you can just attach it here, and it will be, always associated with this particular, asset for the complete life cycle. So whenever this asset is transacted on a network, so that particular file will be always associated with it, and it will be secured, and as you said, it will be distributedly stored on the network. Everyone on the node, when a new node joins in, so he will be downloading all these blocks every on the first time. So right now, as we see that there is some GBs of data which gets downloaded when you join the Ethereum network. So that is the actual block data. Okay. So in this case, when a node joins, so he will be downloading all the blocks on the network. So which is again like having these PDF files in it. Got it?
Yes.
Yeah, just to add on this, this being multi-chain, okay, and we are controlling who can do mining and who can be the admin, etc. So it is not the entire network that would be getting all of this information, depending upon what permissions we give to what user.
Exactly.
Yeah.
Could you repeat last statement?
So I'm saying we can decide which users can join and which users can play what role here. So depending on what permissions we have given for view and for create transaction, that user will be able to do only those operations, which we saw in this demo also.
Yeah, we have not covered that part.
Yeah, I mean, it is this permissions tab, Sunil. So you can see.
We just saw creating, granting, and revoking of permissions.
Yeah.
Okay, so that can be user specific also. Okay.
Exactly. So when you issue this mine permission to a node, that means he will be downloading all the nodes and the data associated. Unless until you don't give this permission, all the data will not be downloaded on his machine. Right? He will be just having these permissions, and he won't be a miner, but he would be connected to a network for some other purposes. Right? That way, you can control it from this dashboard. And that's why this multi-chain is in picture for the private blockchains, where you should be able to control the access rights and the permissions to the nodes based on your knowledge, who is legitimate guy to whom you can give the access, who can download the data, who cannot download the data.
Yeah, as we saw yesterday also, in multi-chain there's a handshake process before a new node can join in or a new user can join in, and the handshake is to ensure that you know the person who is it, right? That is why you cannot directly join in. You have to provide your address to the admin. So that ensuring that handshake process, okay, remains off the blockchain, wherein by some mechanism the user has to provide his address to the admin. It ensures that the admin at least the admin knows the person who is trying to join the network. So I think this was a question some time ago by Nagesh also. How do you know the person in real world? So the handshake process ensures that you know. And when I talked about financial institutions yesterday, I said that financial institutions need to have KYC of people who are doing transactions on their network. Now currently they are able to manage it by doing physical KYC. But when we are talking about cross banks or cross financial institutions interacting with each other, the other guy will not have KYC for this customer. So how would the regulator ensure that the KYC is done or we are dealing with the right person? So that is how multi-chain does it, that at least the admin who's got that guy on the network would have done the KYC or registration for that person, and he would know who that person is in the real world.
So,
Okay.
one quick this thing, Kaka and Sunil, I'll let to just summarize my understanding and just let me know if my understanding is right or wrong. And if you feel that it is disturbing the flow, we can discuss offline. I don't want to disturb your flow.
No issue.
Okay, so suppose now I, Sunil, and our Sharadji, we are three landowners or flat owners, and we are starting this blockchain with these three people. So what we are going to do is, like, as an admin, as an Andhra Pradesh government admin, Kaka will create three records, three existing land records. So my first question is, are these three records three nodes, or three records can go in one node?
No, these will be like three assets, not the nodes. So if you come on the assets tab, it will be assets. Right now there is,
you can create multiple assets.
Yeah,
so,
you can create multiple assets.
Yeah, it could be the government who's creating the assets and assigning it to you for the first time. From there on, whenever you make a sale, it would just be transfer of that asset.
Okay. So in this case, I will create three assets, one for me, one for Sunil, and one for our Sharadji. Now, then you will, as an admin, you will create three public keys and assign these public keys to three of us.
Yeah.
With our assets associated with these keys.
Yes, public key and private key. And private key would be something that you are supposed to maintain secretly, not to discuss with anyone, not to show to anyone. So whenever even if the admin wants to transfer the asset, he cannot do it himself. We saw that yesterday, that even miners cannot add transactions by themselves, because for now that asset to be transferred to someone, that private key has to be provided. That asset has to be signed using your private key, so that when other miners see the transaction, they would be able to find out that it was really you who initiated the transaction. That is why in that system, you would also have a way to initiate a transaction. Basically, it would be you who would be initiating the transaction, signing it using your private key.
Right. So I have one more question. So now I want to sell my property to Nagesh, who is not part of this network. So we initially started with three assets. So assets are still three, but its stakeholders are now increasing to four.
So he needs to join the network. He will also have his own public key and private key. Okay. And obviously, I mean, like any other, right? You want to send money to someone in the bank. They are not in the bank. Can you do it? No. So you have to be on the same network to be able to transact.
Okay.
The sender and the receiver should be on the same network. That's the basic condition.
Okay.
So I have one question more. So yesterday we, as Sunil described, multi-chain, which I have been understanding, means HDFC has one chain, ICICI has another chain, or in the same company, HR can have different chains. Here, what we did, we have from the one Genesis block, we have created one node, then that is the master type we can understand, because that's giving permission. Second, third. So what I can think, as a single department chain we are going to create right now, this are you getting me?
So chain is basically your network. When I talked about yesterday, for example, ICICI would have their own chain. Okay, they would have their own admin, they would have their own miners, right? Similarly, say ICICI Bank would also have their own chain and own network. Okay, which is also on multi-chain, or at least on the Bitcoin platform, because only these platforms are cross-conversational.
Okay, Sunil. It means, Sunil, if we are assuming HDFC case, then ICICI, they have also created their own chain based on their own Genesis block.
Exactly.
Got it. And means which node of ICICI HDFC has to give the permission, HDFC can decide.
Right. So both the parties will decide that this will be the only machine and this will be the only address which can send transactions to you. So there might be other blocks, I mean other guys on the node. If they try to send the transaction, then it will get invalidated because they are not authorized to do that. So that is how we will control it using the grant permission for these nodes.
Okay, got it. By the way, Kaka, this permission, where are we storing and in which format? JSON format in the block itself or somewhere else?
No, that's what I said. I mean, when you change the permissions, right? You saw a transaction number coming up there. Okay, so this again goes on onto the network, and it is again validated whether the admin has made it or someone else, because that again has to be validated by network. So if I'm pushing a transaction for a permission change, so it will create a fresh transaction on the blockchain itself again. Okay, so that means that on the network, people should be voting for me that yeah, this is done by the admin, he is authentic for it, right? So permissions are not stored at the central stage anywhere. It is again distributed on the blockchain.
There is no central concept itself in blockchain. That is what we have been discussing.
So everything that you put in, every piece of data that goes on the block, so it is internally some permission block chain, which is a system chain, I would like to say, and that is managed for the permission changes or the permission transfers, I would like to say.
Okay, because we are creating user and user is also some private public key.
Again, you see for the change permissions form, I have admin address and the for address. That is means this is the sender and this is the receiver. Okay, so this is again kind of yeah. Okay, so now guys.
Yeah, it's clear.
Okay, fine. So now guys, I mean, since this is multi-chain, as you see, we are just on a single chain right now, that is chain one. Okay, but you can create many chains in a single network again. For example, suppose right now we are having this asset called as a flat. For example, I can segregate or categorize my chains, saying that create a chain for residential properties, that will be a residential property chain, create a chain for commercial properties chain, or any kind of use case that I have. That is up to me how I design it. Okay, so that's the beauty of again multi-chain. You can run multiple chains at the same time and you can work on them. So when you land on this page, you see chain one. Again, you can add multiple chains and you can click on that and you can log into that chain and see the transactions and everything about that particular chain. So that is multi-chain. Okay, so now let's come to next concept, that is streams.
Okay,
So as I said,
another question.
Yeah.
This is about the units. So in this example, we have an asset, and that asset, when it is transacted, it can be transacted in the amount money, right?
Yeah.
So one thing which I'm capturing here is the asset, where it is transferring from to whom,
from end to address,
based on the public address and so on. Now, what about the money? How can I introduce the other factor, which is this amount, this particular asset was sold to this public address or transferred with this amount?
We created this EMS coin. So
also you can have custom fields in it. So you can define custom fields in your particular installation. I mean, this is what the platform is offering, that if you want to add additional data, you can add additional custom fields and add it as part of the transaction.
Yeah, for example,
if you see at the bottom, if you see at the bottom, you have custom fields, key and value.
And I can make it mandatory. I mean, I have to specify all this value.
Yes, exactly. Yeah. You can design it according to your use case.
Like a variable. Yeah. Okay. Thank you.
Okay, so now let's come to streams. As I briefly talked about streams in the presentation. So streams are basically time series database. But again, this is not a plain relational database. It is not plain NoSQL database, but it is a database on top of your blockchain. So what happens is in a time series data, just imagine an example like when a chart is built for the stock price. Okay, so those stock prices are recorded in the real time. Okay, so for particular instance, particular second and minute, what is the price that is recorded on the database? Okay, so and that should be immutable because that particular price which is written at that particular instance should not be overwritten or get modified anytime in the future. So that is the requirement. I mean, for such kind of databases and such kind of data storage where there is a huge number of records flowing in, like stock price data, location data. Suppose I'm tracing a location for a person, or suppose I'm building a mobile application in which I want to record a location points for a user who is traveling from one location to another location. So in these kind of databases, you need some high speed, again low weight data storage solution, and again it should be immutable. I mean, there should not be any way that data gets tampered or changed in the future. And that's why the streams are created by the multi-chain team. So they created something called as streams, and this is purely like data storage in a way of I would like to say key value storage. So we'll see how streams actually work. Okay. So I would say that I will be creating a stream to store a price for, suppose I would name it as Reliance stock price. Okay. And this is from address that is the creator of the stream. You will see this again goes on the network. It creates a stream for me. Okay. This is the stream. Okay. Now let's come to publish, and you will see publish to stream. Okay, so this is just a form, but you can use this in a application where you are recording the stock prices and you are pushing on to the blockchain database. Okay, so now I would say that I'm recording stock prices for REL. Okay, so I would say rate, and I would say text. I would say it is 120 as of now. Again, this is very similar to asset, but in a different way. You can upload or you can attach a document or file to it just as a data associated with that particular block. Uh, it is asset, but it is something lightweight and created for faster storage and retrieval purposes. Okay, so I'll publish this first value to this string, that is REL stock price. Okay, and you can see again I get a transaction number. Now just say view streams, and now you can see I have this sorry stream associated with my account, that is this, but I have not subscribed to it. Subscribing to a stream means you are become a subscriber. For example, what happens in stock markets, NSE and BSE records these stock prices, and all the financial companies becomes the subscribers uh, for the stock prices. So let's subscribe me as well, and I would say that I want to become a subscriber to this particular stream or this particular database, I would like to say. Okay, and now I can see the entries against this streams that are associated with me. So I would like to say just click on this, and I can see what are the records currently present on this particular stream. So right now I just have only one entry, that is of 120, and which was recorded. So this timestamp is very important in case of streams, because this is specifically designed to record timestamps in the real world, because this shows me that at this particular time the stock price was 120. Okay, so now let's publish another value to the same stock, and this key is optional. Okay, so you can define what you are actually entering it, or you can again put some location kind of data like longitude and latitude in the value, so that when you're parsing it, when you're retrieving it, you know that how to process that data. But you can associate data in a string, and in any manner and in any size, which is configurable, and which is, up to you how you define and design it. So I would like to say that from 120 it went to 125 just now. Okay, so just go to streams, RU stock price, and see. This is chronological order in which the stream is getting changed. Okay, so data is getting changed. It was 120 at this moment, and it is now 125 at this moment. Okay, so when you're developing an applications where these kind of requirements are there, where you need very faster storage and retrieval key value database. Okay, for such purposes, the streams are created and APIs are present there. You can utilize these APIs and behind the scenes, you are not storing this value in a particular server. There is no central server where these values are stored. These are pushed on the blockchain and these are distributed on the network. People have validated them that this particular, when I'm saying published, so my address is going on the network. So again, this is validated that whether this guy is allowed to or permitted to publish on a stream or not based on the permissions you can see. Okay, so whether I'm able, whether I'm allowed to, send the transactions or not. So that is again validated on the network. So that means your data is pretty much secure, it is authentic, and it is definitely not tampered because it is on the blockchain. Okay, on this stream now you can see if I go to node 2, node 2 is present here because he has the right to send. The permission of sending is given to him. So suppose on the network, node 2 said that it is 126. Okay, publish it and go to streams. Yeah, this guy is not subscribed to it. He's just writing to it. So let's subscribe, and now we can retrieve the data and save it. So this you can see who has published it is also recorded. Who has actually recorded this value is given here. Okay. So in the network, so BSC or NSC might be having multiple servers who are able to record the values. So in that sense, you can configure it like who can actually write the values and who can actually retrieve the values. Okay, the only important parameter which is associated with the stream data is the timestamp. For timestamp is always present with you. You don't have to, enter it manually, and that's why it is used for the time series databases. Okay, guys. So I think I've covered most of it from the today's session. Almost done. Streams was the last part, and there are other things which you can try from these command line interfaces, but most of the concepts are covered here. And yeah, I mean, there is one more project associated with this. This was one of the web interface that I showed to you, which is fairly, I would say, a mini application or a vanilla application built on blockchain, which I can modify as per my requirements, and I can, call it as my own application on the blockchain because it is talking to blockchain. It is, doing transactions on the blockchain, and that's what I wanted.
Kaka, you can just show them Yobi chain, and from there, they can download Yobi chain and set up and try their hands at the example applications.
Yeah, sure. I mean, UB chain is again doing this, and it is again utilizing this multi-chain.
Yeah, it is
And
built on top of multi-chain.
yeah, so this is one more. I would call it as a set of. I mean, it's a composition of 2-3 applications in a one package which you can explore, where again this web interface is present there,
So if you
and they
just,
have
sorry, Kaka, sorry, for if you can just go to the previous screen. So if you see there are two applications here. One is Multi-Chain Explorer is also there. So
yeah,
if you want to set up an explorer similar to what we saw for Bitcoin or for Ethereum, you have a web application there. So you can install this, try your hands on multi-chain development environment.
correct. I demonstrated this one web demo to you guys. So there is one more called as Multi-Chain Explorer. So this is very similar to the Ropstein network that I showed you in the last demo, basically. So these kind of things are present in that Explorer project. So you can see, you can browse all the transactions on the network that are running. You can see who is transferring what, and what are the status of the transaction in the real world, I mean the real time. And yeah, I mean everything that is there on this Ropstein.etherscan.io. Similarly, there is this thing, multi-chain explorer. You can try installing on your VM and explore it. So any questions, guys?
Kaka, just one question. Can I see the REST call which you are making from your PHP code?
Uh, Sorry, you meant to say this application?
Yeah, the application which we are going through, Node 1, Node 2.
Yeah, this I showed here already. I mean, this is the web demo project. Okay.
No, yeah, demo project code I was just.
Yeah, here is the code. You can browse it.
Okay.
You can
Okay,
see
I'll
all.
try to search.
Yeah. This is the
Okay.
code.
So, Kaka, sometimes could you cover me Swarm, Whisper, Hyperledger, Fabric, because these are the terms which are coming frequently and very close to this blockchain.
Agree, but Hyperledger is not part of this course because it is again itself a different platform, and Hyperledger was not part of this program.
Means as like Ethereum, you mean to say?
Correct.
Okay. So could you give some time for Whisper and Swarm, because these are a storage and messaging system for Ethereum?
You want to understand it theoretically or?
Not within 2 or 3 lines, because one is for messaging, one is for storage. This is not sufficient, but I want to how to use these. So definitely it will take 50-20 minutes some time for us to understand.
We'll see if we can.
Not today. Definitely, I think so. Next week we have some time.
Yeah.
And definitely, I agree. Hyperledger, those are totally different fields, but there are many components inside the Hyperledger. I mean, Fabric. There are 2-3 more.
Yes.
So we can get a basic description of that. Means how they are correlated with Ethereum, because concept is same for these two, Ethereum and that Hyperledger.
I'll try to see if I can put something around by the next week, but I will not
promise.
That
will be great.
Yeah.
So thanks. That's all questions from my side.
Okay,
then I think we can close for the day.
Okay.
A very basic question here. Most probably. So, in the case of a digital signature, so how are we going to? How does it comes into picture here? We have to configure a digital signature in the document.
You don't have to configure it. Okay, Okay, I don't know whether to take it for everyone. So we studied about cryptography, I think, in week 1, wherein you have your how you do authentication, how you do digital signatures. Maybe I can pass you, a couple of links which tells you how digital signature works and how it will work here, because it would be repeating a lot of stuff what we covered earlier.
Yeah, sure. Go through that.
Yeah.
Yeah.
Okay. It was Nagesh, right?
Yeah. Yep.
Okay, Nagesh. Yeah.
All right. So we can discuss later, Sunil. That's sure.
Yeah, we can discuss it. Yeah, sure.
Okay, guys. So I think we're almost done with today's session.
Okay, thanks everyone.
Thank you,
Yeah.
Kaga. It was a good
Thanks,
session.
guys.
Thank you.
Thanks, guys. Thank you.